All right, here we go. Numbers. And that ring marker. Number one. One is a calculator problem. Remember in the free response, 1 and 2 are calculator, 3 and 4 are no calculator. So here we go. We have a calculator, we are ready to go. F is an increasing function defined above. The function is given by this equation.
Always in the middle, it always just is like this.
Right, H is defined by the composition. So H, oh wait a minute, F is in the chart. H is G of F of X. All right. So what do? It says find the value of H of 8. So we want to find H of 8. So what do first? We find F of 8. So what is F of 8? Remember, you've got answer sheets. You're writing your answer where you're supposed to. So the value of H of 8 is what? Well, what's F of 8? Look at your chart. F of 8 is 15. So then we take that 15 and plug it into G. So do you see why it's a calculator problem? You're going to plug 15 into here. So go ahead and do that. And I'll tell you what I came up with, and then you tell me what you came up with. You're going to put 15 in here because we did F of 8. And from our table, that gave us 15. And then we take the 15 and put it into G. So see if you get negative 42.75. Is that right? Everybody, you didn't even do it. There's not. Are we okay with that? Everybody follow? All right, now, that was I. Find the value of F inverse of 20 or indicate that it's not defined. So remember, what that means is F of something is 20. So F inverse of 20 would be that thing. That's the inverse relationship. So look at your chart. F of what is 20? 16. So the answer to the question is 16.
What kind of work is it to show on that?
I'm not sure. Remember, I'm not a grader, so I don't know. But I think writing something like this down indicates you know what you're talking about. And then you can just say F inverse of 20 is 16. All right, B. Find all the values of x for which g of x equals negative 45 or indicate that there are no such values. So don't we want this to equal negative 45? So what are we going to do? Remember, it's a calculator problem. You're going to graph it. And you can graph it however you want, either as a single equation or as two equations. But you're going to graph it. And I actually came up with 3 answers when I did it. See if you do too. this is gonna be some kind of cubic thing. And this, of course, is gonna be a straight line. And you should see them crossing 3 times. Let me know, I could be wrong. Again, I could be wrong. That's what I got when I did it. Sawyer, you're looking at what you got. You got 3 points of intersection?
My window's all.
Well, you know your Y has to go down.
Yeah, I'm
Your
not
Y,
getting
yeah, so
there.
you're down there negative 60 or something.
I got 3.
3 points?
Yeah.
Can everybody see the curves crossing
Big
in
battery
places?
is the square.
Jane, where's your calculator?
Never charge it.
How are we ever gonna be dark green if we're not practicing? We have to practice. All right, did you find them? I'll tell you what I got. I got 5.321. 15.410. And 17.269. Can anybody confirm those?
Yeah.
We are rounding to the nearest thousandth or more. Okay,
So they actually do it on the test, so 1,000.
always minimum of 1,000, always. Yep, everything's rounded, if you're rounding, it's gotta go to 1,000. All right, we good on that one? All right. Determine the end behavior of G as X increases without bound. Express your answer using end behavior notation. So you're going to write the limit as X approaches infinity of G of X. That is the appropriate notation. So we want the limit, we're increasing without bound, so that would be X approaches infinity. So you've already graphed it, so you should know that even without the graph, this is a positive coefficient cube, so it looks like this. So as it increases, you should see on your calculator, it's shooting up into space. You use the table of values to determine if F is best modeled by linear, quadratic, exponential, or logarithmic. All right, so I gotta have a T-chart to do that. So 1, 2, 4, already my antenna are up. Because my X's have what relationship? They're exponential. And my Y's, I didn't notice this before, my Y's are what? Linear. What kind of a relationship has exponential X's and linear Y's? Logarithmic, yep, logarithmic. And so, let's see, give a reason based on the relationship between the change in the outputs and the change in the inputs. So what's your logic? The inputs are changing exponentially, and the outputs are changing linearly. If those were reversed, and the inputs were linear and the outputs were exponential, then we'd have an exponential function. Right?
Inputs change exponentially,
Yep.
and outputs change.
Yep. Is that the, are we done with question 1? Yep. All right, let's go to number 3. And then I'll promise I'll shut up and let you work on your own. But I want to get through a couple of these. Now, number 3 is a no calculator. find it's one like we have done before. All right. Okay, one rotation every 2 seconds. So that means my period is 2, right? That's how long it takes it to do a thing. All right, point S on the tip of the arm, and point S is on the tip of the arm, and point X doesn't move. As the arm rotates, the height of S above X periodically increases and decreases, okay? At time t equals 0, S is at its lowest position, 6 inches directly below X. Okay? So what do you want to put here? At 0, what's our position?
20?
What?
20?
No, listen, look at what it says. At time 0, S is at its lowest position, 6 inches below S. And they even kind of label it over there for you. How about we call it -6? Now, when is it at -6 again? 2. And let's just split the difference. What happens at 1? So 1 would be like halfway around. So where would it be at 1? What's the y coordinate at 1? No, not 0. What? Not 14. Wouldn't it be at 20? Look at your thing over there. What's that highest point? How high above? Isn't that at 20? So this is 20. Now, where is it in the middle? Half or 3 halves. Where is it in the middle? So halfway, okay, it's rotating counterclockwise. So halfway, it's going to be, Alex says 13. Is he right? I don't know. Won't it be halfway in between these? So how do we find halfway in between those? Average them? So what's the average of those? 7? Now let's think about that for a minute. That 13 was a good number, but the 13 is the distance between each of these. So it's not where we're at, it's the distance between them. Now where will this one be? Also at 7? Now we have our points. Now we have to figure out where they go on the graph. Okay, so remember, there's no axes. So that's always a confusing part. There's no axes. So they look like this. Here's F, G, J, K, and P. Now, what's our highest point? Let's start right there. What's our highest point we got up there? So this is the point 1, 20. This would be the point 3, 20, because the period is 2. This one is our lowest point in the middle of 1 and 3, so this would be 2, -6. And then that one is between 120 and 2, -6, so this one is 3 halves, 7. And what will this one be? 5 halves, 7. those are your best choices, I think. Here's the school kids. Could this point, as this goes on, could this point have a different name? Sure. But if I used 0, -6 for that point, then these would have negative x's, and x is time in this problem. So I would prefer not to have negative x's. I don't know what the grader's feeling on that is, but I think this makes the most sense, right here. Okay. All right, so that's that. Okay, now we have to write the equation. This is gonna be a cosine equation, and I have to fill in all these numbers. Okay, so if this is a cosine equation, I could start it right here. Now remember, a real cosine is supposed to start at 0. This one is starting at 1, so I have shifted it over. Where does that show up in my equation here? That shows up as C. And do I want C to be a +1 or a -1? -1. So C is going to be -1. Because I'm starting at 1 instead of 0. Now, I also have these zeros aren't really at 0, they're up 7, right? So what does that mean? My midline is 7, so this guy, D, is 7. I know you guys can't see it over there. D is 7. Would you agree with that? This is my amplitude. That's your 13. That's your 13. So A is 13. And the only thing left is the hardest one, and that's the B, which is going to influence the period. What did we say our period was? 2. So if our period is 2, our period is supposed to be 2 pi, but it's been divided by that number. So if 2 is 2 pi over B, then it looks like B has to be pi. So there are your values for A, B, C, and D. This will be, these free response are too consistent. As you look through all of them, they're the same. These are the questions you're going to be asked. You need to nail the free response because you know exactly what they're going to ask you. Okay, so that was that. All right, number 3, finally. Refer to the graph. Points K and P. So here to here, these points right here. What can we say about that? At those 2 points, the curve is positive and increasing. How about the rate of change? The rate of change is positive and decreasing. How do we know it's decreasing? How it came down. All right, perfect. Okay, good. So your homework is to do that.
2 and 4. Do Monday.
Do Monday, because you're all coming to class Monday.
Yep.
And then, I feel like we should do a couple more.
Just the start.
I guess what I'm doing t-shirt is and they like my ideas like they're miniature. Yeah, like it's actually so good. What color is it? I haven't decided color. They're trying to get me a new Wait, what color is it? I think
So
so.
in addition to that,
My eyes were
in addition to that, I want you to finish the practice test 3 multiple choice. So you've already done some of those. I think you did 10 of them or so already. You're gonna finish those multiple choice from practice test 3 and then do the 2 leftover free response from practice test 3. All right? Got it? Perfect.
Hope you guys have a great day.
Next week, like a.
Peace out. I love you all. Oh my gosh.
Listen, good question. The schedule, turn it off. The schedule for next week
Bye guys.